The next very interesting concept is called subqueries. We'll understand what they are. It's a very, very interesting idea. Subqueries are also referred to as nested queries or inner queries, right? So before we go into it, let's take the problem that they help us solve. Imagine there's a very popular movie called The Schindler's List. If I want to see the names of all the actors who acted in this movie, how do I obtain it from my data? Because look at it, I have a table called actors in which I have the first name and last name of actors, right? And for every actor, in which movie, which role did the actor play is actually in a different file altogether, right? Or in a different table altogether called roles, right? Right? And the information about a movie or the ID of a movie, given the name of the movie, is there in movies table, right? Here, the information that we want, look at what we want. We want to list the first and last names of all the actors in a given movie name, right? So this information is split across three tables. There is a movies table where the movie name exists, the roles table which says which actor played what role in which movie, and there is an actors table where I actually have the first name and last name of the actor, right? We'll come to this query. I'll explain you what this query is. But literally the data is split across three tables for me: the actors table, the roles table, and the movies table, right? One way to answer this query is to perform a three-way join. I can obviously answer this question using joins. But is there an alternative way of not using joins but still obtaining it? To give you a more real world perspective, why this is useful, even on IMDb website, if I search for Schindler's List and if I go to the full cast and crew page, it literally tells me all the actors, the casting basically, and what is the name of the role that they played. I'm sorry. Right? So even on IMDb, when I click on the movie name, right, and when I say full cast and crew, it actually takes me through and lists in each of the individual actors or actresses and the roles they have played. It already does this. Imagine if you were to build this web page, right, using the database that we already have. How do we do it now? Right? Fair enough. Very fair enough question, right? So let's look at something called as subqueries or nested queries or inner queries. Very, very powerful idea. Makes life very simple and intuitive to understand, right? So first, let's work it out, right? So I know that the first name and last name are in a table called actors, right? So I'll say select first name comma last name for actors, where I need to get the IDs of each of the actors, right? And the actors table has the actor ID, first name and last name, but it doesn't have the information on which actor ID played which role in which movie, right? So let's look at each of these tables. You have actors, roles, and movies, right? So let's go to our terminal, right, and describe. Sorry. Okay. Sorry. Okay. So describe actors. Okay. Now I'll say describe roles, and I'll say describe movies, right? So if you look at this whole system here, what will you notice? First, to obtain the actor first name and last name, this information is in the actors table. This is in my actors table, but every actor also has an ID, and that actor ID is also present in the roles table. See, this is my roles table. This is my actors table schema or the structure of the data. This is my movies table, right? So this actor ID is present in this actor ID, and the roles table says whether an actor, using the roles table, I can determine if an actor acted in a specific movie ID. But I don't have movie names in the roles table. Given a movie ID, I have the name in a different table called the movies table, right? So you understood the logic here, right? So the way we will flow now is, we will say that we want to print the first name and last name of those actors whose IDs are in this table where the movie ID is the same movie ID which is belonging in this table where the name is equal to Schindler's List. Right? I hope you got the flow of the logic here. Right? So now let me walk you through the SQL query itself and why it's called the nested SQL queries. Right? First thing. First I'm saying select first name, last name from actors where the ID in is the keyword here. Right? In, if you think about it, you say belongs to a set, right? In set theory, in sets, you say, suppose I have a set 1, 2, 3, 4, 5. We say that element 2 belongs to this set 1, 2, 3, 4, 5. Or we can say that element 2 is in this set. That's why this keyword in comes from. So we are saying that we want to print the first name and the last name from actors where the ID is inside this. Right? Is in this set. Now the way this whole thing will work is this. First, for me to print, look at this, for me to print the first name and last name where the ID is in this. First I need to evaluate what is inside that. Look at this. This is like nesting. If you recall, what is nesting in programming? It's basically your for loop. If you have a for loop like this, within a for loop like this, right? This is called nested for loops, right? These are called nested loops. When you have something within the other thing, that's called nesting. So here what do we have? We have an SQL query, this SQL query within the SQL query itself. Because after in, we have this nested subquery, right? So now let's look at what is there inside. Okay. So now it says select actor ID from roles where movie ID in, again it's using this keyword in. Select ID from movies where name equals to Schindler's List. So the way the whole subqueries or nested queries or inner queries work is, it first executes the innermost query. So what happens here? Select ID from movies where name equals to Schindler's List. What will this return? This will return me a set of only one ID. It will just return one ID. I don't know the ID here. Let's say that ID is 126. Let's say let. Okay. So this ID that Schindler's List has is the set, right? First it runs this. First it executes this. Next, the result that you got here. What is the result that we got here? A set of 126. It's a result set of just one value, which is 126. Now, what is the next outer query here? So this query is already executed. This value needs to be used in this query now. Select actor ID from roles where movie ID in 126. So this is executed next. Okay. So if the movie ID is present in this set, then please print all of the actor IDs. Now this will return a subset. So this will now return a set of IDs, actor IDs. Right? It will return a set of actor IDs. Now the outer query, let me change the color again, right? So now the outer query will be executed. This line, select first name, last name from actors where ID in. Here after in, this set is used. So if there is an actor where the ID is present in these set of actor IDs, their first name and last name is printed, right? This is the third. So the way of execution is innermost, you keep coming out. Just like in your for loops in programming, right? You first execute. Suppose if you have a for loop within a for loop within a for loop, right? First this loop is executed, then this loop is executed, then this loop is executed. Very similar concept here, nothing very fancy, right? So now we'll learn more things. So we have learned about the keyword in here. In is basically testing if this ID is in a set, right? In can be thought of in set theory as belongs to. Okay, does an element X belong to a set, let's say S? Okay, that's what it's testing. Now there is a general syntax here for all subqueries, nested queries or inner queries. I hope this terminology is clear. It's called nested or sub or inner queries because of the structure, right? So this is a nested query with two layers of nesting. There is one layer of nesting here and one more layer of nesting. But the simple syntax is select column names, whatever column names you want, from table names, where column name with some operator. Here we are using the in operator, right? Some operator. We'll see other operators in a while. And then I have my subquery within it. Okay, as we just explained, first the inner query is executed, then the outer query is executed using the output values of the inner query. So a few operators that we can use here are these. There is in that we saw, which tests whether an element X belongs to a set S. That's what your in is, right? Your not in is exactly the equivalent. Does X not belong to your set S? This is what is your not in. All these are operators that we can use. Exists. This is a very interesting thing, right? Exist. We'll see how exists is useful. So exists basically says it will return true. Okay, exists basically returns true if a subquery returns one or more records or null value. Okay, so imagine I have a query. Okay, let's go here. Okay, so if I have the exists operator, right, this will evaluate to true if I say instead of in, if I say exists. If I say exists here, if this subquery returns null or one or more records, if this subquery, if the set that it results in is not an empty set, okay, it has at least one element or more than one element or null, then whatever you want in the result here, you will get it. That's what exists means. Similarly, there is something which is not exists. Then there is an operator called any and all. We'll see an example with any and all, right? So any basically means, okay, it returns true if any of the subquery values meet a condition. I'll show you an example. Okay, I'll show you an example so that any and all becomes clearer. All basically returns true if and only if the subqueries meet, if and only if all of the subquery values meet a condition. See, at the end of the day, your subquery is giving you a resultant set. Okay, if the values in the subquery meet all of the conditions, then the all will return true. If any one of them satisfies a criteria, then you would get true if you are using the any keyword. Let's take a simple example so that this is clearer, right? So let's look at it. Suppose if I want to obtain all the movies whose rank score is same as the maximum rank score, right? So let's look it up. Okay. So I'm saying select star from movies. Okay, select star from movies where rank score is greater than equal to, till here, this is straightforward, this is straightforward. This is where the fun part starts. Okay, where the rank score is greater than equal to all. What does all mean? As we saw here, all means all will only return true. Sorry, not any, sorry, all, right? All will return true if and only if the subquery, if and only if all of the subquery values meet a condition. Okay, now let's look at the subquery. What is the subquery saying? The subquery will result, okay, will print or will result in a result set, which is the maximum rank score from movies. Okay, let's assume the maximum rank score is one value, 9.9. I think this is the maximum rank score in the whole IMDb dataset. So what does this inner query result? This inner query results in a result set with only one value, which is 9.9. Right? First step. Next, what is happening is, after it has returned this value 9.9, we are applying this greater than equal to all this. So what does it mean? So select star from movies where rank score is greater than equal to all of these values. There is only one value, but all of these values basically means what? So print only those movies where the rank score is greater than equal to. This is the comparison operator again, right? Where rank score is greater than equal to all of these values. That's how you read it in English. Okay, I'll repeat it just for clarity, right? First, let's execute this. Once you execute it, you get a resultant set, which is 9.9. This set can contain one or more elements. In this example, it contains only one element. Now I'm saying select all the columns from movies where the column rank score is greater than equal to all the values that are in this. Obviously, there is only one value and this value is the maximum value. And hence, I'll only print those movies where the rank score is greater than equal to the maximum value, which means equal to the maximum value, because there can be nothing greater than the maximum value, right? So we could have written things like this also. Just like the way we have used the greater than equal to operator, we could have used the not equal to operator also, right? We can use comparison operators like this. So in nested subqueries, we can use in, not in, exists, not exists, any, all, and comparison operators like greater than equal to, not equal to, etc. Right? I hope this is clear, right? The beauty of, or the ease of nested subqueries is they're extremely easy to read, because this is how we think, right? Logically. Joins are much more tricky, right? This is a very, very simple thing, because all that it is doing is basically checking if something is in a set, or if all the values in a set are greater than this, or even at least one value is greater than this, and things like that. So nested subqueries are much more readable. They're much more easy to read than your complex joins. Of course, we could have achieved some of this using very, very complex joins. But nested subqueries, in a nutshell, enable us to do things and write SQL queries which are much more simpler and easy to read. That's very important, right? Readability, because you could have written a SQL query which someone else has to read tomorrow your code, right? Code readability is also an extremely important part of software engineering, right? Whether you're a software engineer or a data scientist, it is super important. Okay, so there is another concept called as correlated subqueries. The best place to learn that is Wikipedia. As you all know, we use Wikipedia extensively throughout our courses, so that because it's one of the best sources, exhaustive sources, very reliable source with lots of details. So correlated subquery is as follows. Let's understand what a correlated subquery is, right? So this is a very nice example. I mean, the examples that you sometimes find in Wikipedia are very well thought of, written by experts, or modified and updated. They're very nice actually, right? So let's understand this. So we have a query like this. So we have a table called employees here. EMP is basically an alias to it, right? Let's assume I want to print the employee number and the name, right? Till here it's straightforward, right? So I have a table called employees, right? Where I'm using this alias EMP. My alias to the table is EMP. Everything straightforward till now, right? Select this, where salary is greater than, see here we are using a comparison operator, right? Then within the nested query, I have this. This is my nested inner query. This is my inner query. This is my inner query. So what is there in the inner query? Let's look it up. What is there in the inner query? The inner query says, select average salary from employees, same table. My employees is the same table, where the department is equals to emp.department. So what is this eventually achieving? If you think about it, let's think about it. What is the inner query going to record? What is the inner query going to return you? For this employee, right, whatever is the department, right, it's going to compute the average salary, right? It's going to compute the average salary, and it will print those employee number and names of employees whose salary is greater than the average salary within that employee's department. That's very, very important. How do I know that within that employee's department? Because I'm using the EMP here, right? So what is this achieving in a nutshell? That's very, very important to understand. So we are trying to print the employee number and name from my employees table, where the salary of the employee is greater than the average salary of all employees whose department is same as this employee's department, right? So what I'm listing here is per department, list all the employees whose salaries are greater than the average salary in that department. Literally, that's what I'm doing here, right? Now comes the fun part, okay? If you look at this, this is called a correlated subquery. This is very important. This is a slightly different form of subquery. It's called a correlated subquery because for every employee here, look at this, for every employee here, I need to run this whole subquery again and again and again and again. Because for every employee, the emp.department changes, right? So because I am using the information in the outer query, see, I'm using the information that I need in the outer query in the inner query. This inner query needs to be run for every employee, which means even though employees belong to the same departments, I'm computing the average salary per department again and again and again. Right? So this is very, very interesting. So every time I get a new employee, right? For example, let's assume I have employee 1. I'm just stating, okay? So I have, let's say, employee 1, some name E1, some department D1, right? Employee 2, right? 2, same department. So on and so forth. So first time when I see this, right? Because the employee department is D1, I have to compute the average salary within the department and see if this employee's salary, right? Let's assume I also have a salary column. I need to have a salary column, right? Right? Let's assume this employee's salary. Now I need to compare this employee's salary with the average salary across this department. So while deciding whether we should print the first row's ID and name, we are computing the average salary for this department D1. Now let's go to row 2. Row 2 again belongs to D1. His salary is S2. Now I need to compute the department D1's average salary again, because that's how my nested query is written, right? So every time I go, if the same department repeats, I'm computing the average salary in the department every time. This could be computationally expensive, right? Of course, your query optimizers, see, there is something called as a query optimizer in a database, right? Some query optimizers will understand this fact because they're fairly smart. I mean, the way query optimizers are designed, they're fairly smart. They will actually store the average salary of the department in a temporary buffer and reuse it. But not all query optimizers are guaranteed to do it in all situations. This is a fairly simple and straightforward situation of a correlated subquery. This is called a correlated subquery because we are using the information in the outer query within the inner query. Right? So this is a tricky case. This is because this can become computationally expensive, right? So of course, there is a whole subject called optimizing correlated subqueries and things like that, right? Of course, as usual, Wikipedia has tons of nice articles in general with lots of references also. So for example, if you want an external link on correlated subquery with examples, right? If you just go here, let me see where it's taking us. Okay, it's taking us to another website where there's a lot of discussion on SQL subqueries in general and how to optimize and things like that, right? So my suggestion, as always, is to use Wikipedia extensively. And overall, in a nutshell, your inner queries or subqueries help us make your select queries, or in general any queries, more readable. That's one of their more readable and easy to understand instead of complex multi-way joins. That's one of the most important properties. But we could get into cases like the correlated subqueries, which we need to be slightly careful of.